Here in number 2, they're asking you to find the sine of negative 270. So first we're going to graph the angle and see if we can draw a special right triangle to match. And if we can, then remember sine is opposite over hypotenuse, right? Okay, so negative 270 is a negative angle, so we have to go down and around. So this is negative 90, negative 180, negative 270. All right, so because the terminal side lands exactly on the y-axis, or if any angle lands on the x or y-axis, that is considered a quadrantal angle. That means it's stuck between two quadrants. So right now 270 is stuck between quadrants 1 and 2. What this means is that we're not going to be able to use a traditional ratio of opposite or hypotenuse because we're not going to be able to draw a right triangle that goes with this. Quadrantal angles do not have a reference angle, and because they don't have a reference angle, I can't draw a matching right special triangle like a 30, 60, 90 or 45, 45, 90. Remember, reference angles have to be less than 90. So what I'm left with is the idea of the unit circle having coordinates for quadrantal angles, right? So there are essentially 4 of them, but here we're just going to focus on the ordered pairs for 270. The ordered pair for 270, if we're dealing with the unit circle, right, is 0, 1. So remember, the unit circle has a radius of 1. So all those quadrantal angles are always going to have a 0 and a 1. You just have to use common sense where it's 1, 0, 0, 1, etc. Sorry, my screen keeps jumping. Now, all ordered pairs for quadrantal angles, okay, instead of being just x, y, you have to know that the x represents the cosine of the angle and the y represents the sine of the angle. So since they're asking us for the sine of negative 270, they're asking us for the sine, which is the y value. Let me know if you have any questions. Again, we could not draw a special right triangle of 30, 60, 90, 45, 45, 90 because quadrantal angles do not have a reference angle.